Our question is the following series convergent or is it divergent? The summation of 1 divided by n minus 3 to power 2. And if it's convergent, what does it converges to? What's the limit of the partial sum? First of all, we have a very nice test that we call it the integral test. This test says if f is a positive, continuous, decreasing function, on an interval 1 to positive infinity, then we can assume f to be our an, the general term. Well, if you have a nice function, we can convert that series into the integral. The series the summation of an and start from 1 to infinity is convergent if and only if and only if its equivalent integral is convergent. The integral of f of x dx from 1 to infinity is convergent. So this is an integral test. Can we apply integral test here? We need to check each one of these one by one. First of all, is it positive? Our f of n is equal to 1 divided by n minus 3 to power 2. Well, if you write it in x, make it easier to deal with this function because eventually you want to take the derivative. So let us write it as f of x. F of x is x minus 3 to power 2. Obviously, this is a positive function. We can use Desmos, take a look at the graph of this function. Let us pull up Desmos and take a look at the graph, the behavior of the graph here. This is 1 divided by x minus 3 raised to power 2. So take a look at this function. As you can see, the function is above x-axis, or it is only on positive part of y-axis. So the very first condition is met. So this condition is met. What about the second condition? So we saw the graph. To be on positive part of y-axis. What about the second condition? Is this continuous? Between 1 to positive infinity, we saw that the graph is continuous. So the second condition also met. This function has a vertical asymptote at at x equals to 3 and the function is continuous on both intervals on the left and the right. So here we are taking a look at the graph from 4 to positive infinity. So let us stick to 4 to positive infinity. What about the third condition? The third condition is, it says, is it decreasing or not? This is number 3. Okay, to be decreasing, for the function to be decreasing, the derivative of the function needs to be negative. So is the derivative of this function negative or not? So my f of x is equal to 1 divided by x minus 3 to the second power. If I were to take the derivative of this function, I'm going to apply the quotient rule. The quotient rule says if you have p over q and you're taking the derivative, it is p prime q minus p q prime divided by q squared. So the derivative of this function is 0 times x minus 3 to power 2 minus 2 times x minus 3 divided by x minus 3 to power 4. But take a look here. What do we have? After simplifying everything, you get negative 2 times x minus 3 over x minus 3 to power 4. I'm not simplifying this because I want to analyze this. Do not simplify because it makes it easier to analyze this. Why is that? On the denominator, this guy has power 4. When you have a quantity raised to power 4, it is always positive. On the interval 4 to positive infinity, x minus 3 is positive as well. So the only thing that you need to check is the multiplication of negative 2 by x minus 3. So obviously, negative 2 is a negative value. Negative times positive makes the whole fraction to be negative. So this guy is a negative expression. So it means that our derivative f prime of x is negative. What's the meaning of that? It means that our function is decreasing. So since f prime of x is negative, so the function is decreasing. Very good. So take a look. We checked all of these conditions. It is positive, it is continuous, and it is decreasing. What's the meaning of that? It means that we can apply the integral test. Since all 3 conditions are met, we can use the integral test. So let us take a look at the integral of this function. The integral of 1 over x minus 3 to power 2 dx, x starts at 4, goes to infinity. How do you take the integral? To take this integral, you can basically use u sub. Let u to be x minus 3, du is just dx. So this guy can be written as the integral of du divided by u squared, which in turns is -1 divided by u, and you can write this guy as -1 divided by x minus 3 to power 2, and x ranges between 4 to positive infinity. If you plug in infinity, you get -1 over infinity, minus if you plug in 4, you get -1 divided by 1 squared. So you have 0 plus 1, which is equal to 1. So the integral is convergent or approaching to 1.